All right, kids, what we have going on today is a review for your solving rational equations. So, if we look right here, we see that I have a lot of problem number 2 listed fractions, so you're all really thrilled about. That right there scares the living daylights out of a lot of you, but it's not that bad. So the first thing I need to do is I need to subtract 7 from both sides. Remember, in order to do any of this work, I need to isolate the thing with the radical or rational exponent, which is at k to the negative 7/5. So I subtract 7. How do I do that? Common denominator. That denominator is 64. That denominator there is 1. So I just make negative 7, 448 over 64, which reduces down to 7. Subtract across the top, I get negative 1 over 64 equals that negative 2k to the negative 7/5. I then divide by that negative 2. Which would then get rid of the negative right there and multiply the bottom number by 2, making 128. Then I take it to the reciprocal exponent, which is negative 5/7. The reason I do that is because when you have a power to a power you multiply, these two things would cancel out, and this number spits you out 32. Not bad. Moving on. Here. All right. I don't need to do any work first because that rational exponent is isolated. All I'm going to do right now is take the reciprocal exponent to both sides of my problem. Boom, that's giving me 64. Then I have negative 8 minus 6x. I add 8 and divide by a negative 6 to get me negative 12. I don't do that work first because it is inside my rational exponent. Now here, before I can take care of that 3/2 power, I've got a little work to do out in front here first. So what I end up doing is I subtract 6 from both sides, giving me 2048, and then divide both sides by 4. That gives me 512. Now I have the item with the rational exponent isolated. So I take the reciprocal exponent to both sides, 2/3, gets me 64. Then add 23, gets me 87. 3/2 power, again, subtract 6 first, and then divide by a negative 3. I must do that in order to isolate the item with the exponent. Then I take the reciprocal exponent of 2/3 to both sides, because when you have a power to a power there, you multiply. Then the gooey nougaty center falls on out. It's 3b plus 4, and 64 to the 2/3 power is 16. I then subtract 4, gives me 12, and divide by 3, which is 4. Again here, same idea. Negative 4, add it to both sides. Then I have a 2, divide it. Now look, the item in question I take to the 2/3 power, because that would cancel out that exponent there. That's 81, then subtract 37, and divide by negative 2, and p equals negative 22 there. We did 7 in class together. All right, 8. 8 here. I first must divide by a 4. That gets to be 512. Now the reciprocal of 3/2 is 2/3. I take that to both sides. That gets me 64. That gooey nougaty center falls on out. That's negative 2 minus 11k. I'm going to add that 2 to both sides. Negative 11k equals 66, and divide by negative 11. All right, here. Again, before I can do anything, I have to get rid of the items in front of and behind the item with the rational exponents. So I'm going to add 8 to both sides. That gets me negative 1024 equals this stuff over here. And then I divide by negative 2. I have now isolated, if you see there, I have isolated the item with the exponent. So I take it to the reciprocal exponent of 2/3. That undoes itself, and I get 9x plus 10 equals, and then 512 to the 2/3 power is 64. I then subtract 10, and then divide by 9, getting x equals 6. All right, now here. All right, so I divide by negative 5. Boom. Get positive 4. Take it to the 3/2 power. Now remember, the issue with this problem is, unlike any one we've done so far in this little video, see how my numerator is an even number, when it's even, and I take the reciprocal power to both sides, I end up getting a plus or minus. So 4 to the 3 halves power gets me 8, but because it was originally a 2, I get a plus or minus 8, and then equals negative 21 minus x. That's going to require me to split it up into two separate problems, where negative 21 minus x equals 8, and negative 21 minus x equals negative 8. I still go through the same process of solving, adding 21 to both sides, getting me 29 equals negative x, and 13 equals negative x, and then I divide by negative 1, yielding me a negative 13 equals x and a negative 29 equals x. Yes, they can both be negative, and they could both be positive. You just have to be careful of that. Those are tricky. So whenever you have an even exponent to start, you're going to need to do that. Now here, odd exponent, so nothing really happens special later on. I'm going to add that 4 to both sides, and then divide by that negative 4 to both sides. I have the thing with the exponent isolated. The original exponent is 5/4. I take the reciprocal of 4/5. 243 to the 4/5 is 81. I subtract 29 and divide by negative 2. In the piece de resistance, I'm going to subtract 9, and then I'm going to divide by negative 2. Isolating the thing with the exponent, take the reciprocal power of 3 halves, then 512 to the 2/3 is 64. Subtract 39 gets me negative n equals 25, and then divide by negative 1, get me negative 25. Thus end this video. Now, you can watch this as many times as you want. Feel free to enjoy it. Maybe you're on the bus ride home or after dinner. And hopefully this helps you out. This review also would help you out for your chapter test, which will eventually be upcoming. So it's not a bad idea to have this in the back of your mind. Oh, happy days are here again. Woo!